Hey guys, welcome to lesson 1.3, where we're going to be looking at basic plot types. One of the data sets we're going to be working with in this lesson is the Pittsburgh Steelers data set that is available on our datasets Canvas page at the very top. So if we look at this data set, you have the player name, position, position type, age, height, weight, years of experience, college. So the quantitative data sets are the ones where we can find things like the mean, median, range, etc. So age, height, I changed the height from feet and inches to straight inches because it's a lot easier to do math on that. Weight and years of experience. One of the first graph types we want to look at is a dot plot. So as before, we're going to be working with Statplet, and we want to take a look at the set of ages for the players. So I'm going to go to Statplet. I want to look at one quantitative variable single group. Open that up. Variable name will be age. And I want to take my player ages, copy and paste that into Statplet. So I'm going to do that now. And it looks like this. So with a dot plot, each of the dots represents a single player. And a dot plot is especially useful when you're working with discrete data sets, so countable ones. So it would not be very useful if I was working with like weight, because there's so many different weight types. It would just get crowded. But for something like years of experience or age, working with a dot plot is very useful. All right. So the second type of graph is, and this should be a 2. Graph type 2 is a histogram. Looks like all 3 of those. That's something that I'll need to change on my notes. So I can take this data set of ages, and I can change that into a histogram. So here, each of these bins represents 5 different ages. Now, if someone's 20, they're going to be included in the one on the left. So you can see the 20 is inclusive and the 25 is exclusive. So if somebody's 25 years old, they're going to be in that second column. Now, I can also change my histogram. So instead of each bin being having a width of 5, I can make it a width of 2. And in this case, that gives us a little bit more variability and gives us a better sense of where the players are. So something like weight would be very helpful to put in ranges and use a histogram for that. So a box plot, same thing. I can go back, I can change it to a box plot. So the nice thing about a box plot is it includes the minimum, the first quartile, the median, the third quartile. We'll talk about what quartiles are in a second, and the maximum. So this whisker over here is the biggest element that's not an outlier. So we'll talk about what outliers are later. Basically, they are data points that are significantly different from the rest of the data set. So there's a player on the Steelers who's 42 years old, who is significantly different from the rest of the players. But this player, who's 36 years old, kind of still fits within the range of kind of more normal outcomes. Yeah, so the nice thing about a box plot is it kind of gives you these 5 numbers, the minimum Q1, the median Q3, and the maximum. And it's called the 5-number summary, and we'll discuss that in more detail in a bit. We can also look at so on Stapplet, for example, I can include a box plot to go along with another set. So here's a box plot with a histogram, and I can do a box plot with a dot plot. And the combination of a dot plot and a box plot gives you a lot of information. So a dot plot gives you all the raw data. So for example, on a dot plot, I can tell there are 5 players who are 27 years old. It allows me to count things. So when I'm describing a distribution, describing one of these graphs, there's 4 things that I want to talk about. So a distribution of a quantitative variable is the overall pattern of how often the possible values occur. For most quantitative variables, you want to discuss 4 characteristics of the overall distribution. So you want to talk about the center, and most often we'll talk about the mean and the median. Where is where's the center of a distribution? The spread, how far it goes left and right. So we'll talk about the range, interquartile range, and standard deviation. The shape, is it symmetric or skewed? How many prominent peaks? So for example, for something like this, it's the median and the mean are right around 27. So this distribution of player ages is kind of centered right at 27. And we can talk about the spread, how far left, how far right. That makes a big difference. And the shape, it's not symmetric. You can kind of tell by this that it's not symmetric, and you can tell by this that it's not symmetric. It's kind of like more extended to the right, and we'll talk about that as we'll define what that is. And the last thing you want to talk about is outliers. So are there some data points that are significantly different from the rest? And for example, in this example, we have exactly 1 outlier. Let's look at some math when describing a distribution. So here I have a statistics professor who has 10 students enrolled in her class. One of the students is a returning professional, so the student is older, and I want to find the mean and the median of this distribution. All right, so I have 10 students. So to find the mean, I'm going to add up all the students and divide it by 10. So if you have to do this on an exam, you will have access to Desmos. So on Desmos, 23 plus 24 plus 24 plus 25 plus 26 plus 27 plus 29 plus 45. So plus 27, 29 plus 45. I have 267. So 267 divided by 10 is 26.7. So mean is 267 divided by 10, which is 26.7. The median is going to be, once I have all the students in order, so make sure all the students are in order. So make sure data is least to greatest. And the median is going to be, in this case, I've got 2 students in the middle. So I'm going to average the 2 plus 25 divided by 2. And that one's going to be easy. That one's going to be 25. If it was 25 and 26 in the middle, I would average those 2 and I would get 25.5. All right, so same thing. Now I've got 9 students. So with 9 students, I want to find the student that's exactly in the middle. So 1, 2, 3, 4, 5. There's the median. So quartiles, the lower quartile, or Q1, is the median of the lower half of an ordered data set. So here is the median. And Q1 is if I took all the data to the left of the median and I found the median of that would be Q1. Upper quartile is the median of the upper half of the data set. So let's look at what that would, how that would look on our data set. So here I'm back to the 10 students. My median was 25.5. So my median was right in between those two 25s. Okay, so to the left of the median, I have five data points. So the median of the data to the left of the median would be 23. That would be my Q1. The median of the data to the right of the median would be 27. That's my Q3. Range is just max minus min, which is 45 minus 22, which is 23. And the interquartile range is Q3 minus Q1, which in this case is 27 minus 23, which is 4. So the 5-number summary is minimum, Q1, median, Q3, and max. And those are very easy to figure out from the box plot. So I've got my minimum, got my Q1, I've got my median, I've got my Q3 over here. So the edges of the box are Q3 and Q1. And in this case, here is my max. So the 5-number summary divides our data into quarters. Each of the sections contains roughly 25% of the data. The bigger the data set, the more accurate that 25 becomes. All right, so let me see. So right in here, between Q1 and the minimum, so that contains 25% of the data. This contains 25% of the data. This contains 25% of the data. And then between Q3 and the maximum, this contains 25% of the data, roughly. So each of those, I've got 5 numbers, and they separate the data set into 4 quarters. All right, so for a stem plot, let's look at the weights of the 53 players. So I'm going to go back to my data set. Now I'm going to select the weights. And I'm going to go back to Staplet. And now instead of, I'll do weight, put my data in. So it looks like this. And you can kind of see why a dot plot is not terribly helpful when you're looking at something like weight, where a lot of the players have, like most of the players, have a fairly unique weight. But it helps to put them into bins, so like a histogram would do the trick. So here is histogram. We don't want a width of 2 anymore. Let's say let's try a width of like 10 or even 15. That looks pretty good. And we can superimpose, or we can put a box plot there to kind of give us an additional insight into what this looks like. So notice this sort of distribution, when I'm looking at the distribution of weight, the shape of it, you kind of have 2 prominent peaks. So this would be a bimodal. This would have a bimodal shape to it. Now, a stem plot, I have a stem right here of the players. So this this represents 160, 170, 180, 190, in this case 200, etc. So there's one player that's 162. I have two players that are 174 and 179. So here these players are 310, 312, 313, etc., etc., etc. So you can look at the key. So the nice thing about a stem plot, or a stem plot, is that all the raw data is there. You can tell exactly how much every single player of the 53 players weighs. So this gives you the histogram gives you a good sense of shape, and a stem plot gives you a good sense of the raw data. Now we're going to take a look at the other data set we have. We're going to look at the US Senate data. And I want to take a look at the ages. So I'm going to download this, open it up. Bring it over here. So I want to compare and contrast the ages of the senators based on gender. So I want the women on one side and the men on the other side. The way I'm going to do this is I'm going to highlight my 100 senators. And then I want to, let me take a look. I want to sort the data based on gender. So now all the men are first and all the women are second. So I can make, I'm going to go back to Staplet. Now I'm still doing one variable, which is one quantitative variable, but now I'm going to have multiple groups. So my variable name is age, group name, women, men. So let's get the women first. Let's take all the women and put that into my set. And we'll take all the men next. Put them into my second one. So here's the dot plots. I can look at histograms of the different ages. Change the interval width. Gives me a sense of how old the two groups are. You can look at the relative frequency. That gives me a better sense. So you can see for the women, there's quite a few, roughly 30%, so 0.38. 70% of the female senators are in the 70 to 75-year-old range. Now, I want to look at stem plots. So for stem plots, now I have women. There are two women in their 40s, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 men in their 40s. I can also split the stem, so I'm going to do that. So because it's so crowded, because it's like, for example, for the men, there's so many men in their 50s and 60s, it's getting kind of crowded here. I can split the stem, and now anyone who's 40, 41, so I'm going to copy and paste this and give you a sense of so I'm going to split the stem. So this might be a better. So like for the 50s, anyone who's 50 to 54 is going to be in the first stem. And then 55 to 59 second stem. And same thing, so 60 to 64 in that first stem, 65 to 69 in that second stem. So the nice thing about back-to-back stem plots is they make it pretty easy to compare the distributions of raw data for two groups. So let's talk about strengths and weaknesses of the 4 different graphs. So dot plots, we can see all the individual data points. One of the weakness is they can get too cluttered with large sample size. So we saw that with the weights of the football players. Strengths and weaknesses of box plots. They're really nice about summarizing the 5-number summary. You can also know for sure whether a distribution has outliers or not. So they're excellent in comparing 2 or more groups. Weakness, symmetry and skewness can be judged, but they're not entirely useful in judging shape. So for example, you don't know if a data set is bell-shaped or whether it's bimodal. We looked at an example earlier where I have a bimodal distribution, but if I look at that on a box plot, it's not going to show up. Histograms, they're excellent for judging shape, and with moderate or large sizes. Basically, the bigger the data set and the more continuous it is, the better a histogram is for doing so. And you want to stick to between 6 and 15 intervals to get a good sense of the shape. Weakness, with a small sample, it's not great with small samples, just because you either have too few intervals and they're not tall enough. They don't give you a good sense of shape. Stem plot, it's great at pretty good at judging shape, and it does give you raw data. So does give raw data, which is something the histogram does not. So a histogram just kind of gives you roughly where things are located, but it doesn't give you the raw data. Weakness, with a large sample size, it can get too cluttered because the display shows all the individual points, and compared to a histogram, we're restricted for choices and intervals. Depending on, you want to be able to know how to navigate all the different graphs and basically know the strengths and weaknesses of each of them.